Okay, we're going to get started here. Looks like we have a few viewers now. Hopefully some of you guys are students. So, and Mike's cracking out the popcorn and he's not sharing with me, which is kind of sad. So, I'm going to talk to you a little bit today about debugging Python, deep diving into code, solving very hairy problems. And this is basically kind of a shorter version of what I went through last night. It kept me up until almost 5 in the morning. So I'll kind of be going over a really interesting problem that we hit and how I kind of solved it in roughly the same way that I actually solved it without the, you know, 45 minutes of banging my head against a wall. So let me start off by showing you the problem. We write a product called PowerPack. PowerPack is an add-on product for Review Board, our code review tool. And PowerPack provides a bunch of interesting features. Things like reviewing PDF documents and looking at reports of code review productivity within your company. And I've been doing some work on this lately, and I wrote some new unit tests last night. Unit tests being designed to test that certain things are working correctly, catching problems. And these are the tests. We have this enable function on a class, and we have two different modes where it can run in. One is the first time setup, which is right here. And in this mode, the very first time you enable this feature, which is basically something that helps scale out review board servers, it does some work where it imports some data into your database. And we store a little flag, this thing right here. SSHDB key is imported. And this only happens the very first time. Subsequent times, that's already going to be set. Now, we wanted to make sure that both of these cases worked correctly, that the feature was enabled correctly based on whether it's the first time or the second, third, 100th time. So I wrote these unit tests. Now, they're mostly the same, mostly do exactly the same thing. But when I run the unit tests, they fail. Let me show you that. Okay, one test failed. Now you'll see here this error. Function object has no attribute called. Well, Python functions don't have an attribute called, so why am I even trying to look into this? So we have a concept in our unit tests called function spies. A function spy is a way of listening in on some function, whether it's something under your control or something that's in some third-party library, and seeing if it's been called, how many times it's been called, what it was called with. It also lets you kind of override that functionality of the function. So we use this in the unit tests here. We spy on two functions. One is called enable SSHDB, and one is this save function for the extension settings. When we set that flag right here, we want to make sure that we not only have set it, but we've actually saved it back to the database. So we're listening in on this, and we're checking later on that it was called. When you set a spy, we actually are taking the function, so in this case the save function, and we're replacing it with something else. It's a kind of a wrapper around the function that has some additional state, and one of those is called. Called lets us find out, has this function actually been called since I started spying on it? Now, what should be happening here is that I should be getting, yes, I should be getting true. What I should not be getting is this error saying that it doesn't have an attribute called called. So last night I hit this and I'm thinking this is very strange because I've got two unit tests here that are basically identical. One of them passes, the other one didn't. And the one that didn't pass claims that this is a function, a standard function. It's not a spy. It's not that specialized function. It should say function spy. So why is that? And I was trying to figure this out for a while, and it just got crazier and crazier. So here's what I started off doing. Obviously the unit tests failed here. So I decided, well, let's go take that one function, the one that failed. Let's isolate that. So what I'm going to do here is I'm going to run our test suite. And I was running just this set of functions here, these three functions. Like, okay, well, let's go do something. Let's go ahead and run just the one that was failing before. And that's going to be test enable without keys imported. We let it run. And hey, look at that. It passed. Well, that's bizarre. It should fail. So let's go back to running it before. Make sure that it's actually reliably failing here. And apologies if you hear a train in the background because I live across from train tracks. See, it fails again. Same thing. The function object has no attribute called. It's very strange. So I decided, okay, let's go ahead and try something a little bit different. Let's go delete all this code, the stuff that fails. Let's go take the stuff that we know works. Let's dump it in. Part of debugging things is trying stuff, figuring out what is breaking, how is it breaking, what kind of things can you do to change that behavior, and why did that work or not. So one thing I'm trying here is saying we're going to take what we know is working. We're going to put that into the one that doesn't work. We're going to verify that there's not some typo in here someplace that might be causing this. So we run this again. Still fails. Bizarre. So at this point I realize the problem is not in our test suite here. The problem is something a lot more fundamental. And that's where the hard stuff comes in. This is where debugging gets a little bit hairy, because you've got to start figuring out what fundamental thing that I'm relying upon, that I've assumed has been working right all this time. What is that thing that is failing? And it could be a number of things. So what I did last night is I started looking into what part of this might be causing this save function to be overridden. I had a few theories. One was that, well, maybe somehow the settings object is getting replaced. It could be, right? Like you could be, somehow in this process, that settings object might be replaced by a new settings object. That's pretty easy to test. So I'm going to modify my test. Say old settings ID equals, we're going to do ID of self.extension.settings. And what this will do is print out the, basically like the pointer address kind of for this settings object. I'm going to go ahead and do that there. I'm going to do it down here. And what I should be able to tell from this is, has this thing actually been replaced? Because if it was replaced, then of course we've got a new save function. It's not the same one that we overrode earlier. Let's give it a try, see what happens. All right, we've got some new debug output here. But here's the odd thing, the IDs are the same. Okay, so now we know that there's one settings object we're working with. It hasn't been replaced, but that function sure has. So that's strange, right? How has the function been replaced? Well, maybe it hasn't. Let's do a similar thing. Let's go ahead and find out what the function is. All right, we're going to go print out the functions in both cases. Beforehand, it should say it's just a bound function. Afterwards, it should say that it's a spy. And actually, we're going to go ahead and do that right here. Let's say before we do anything complicated, we're going to go ahead and check the original, check what it ended up being after we spied on it, and check what it is right before we run the assertions for the unit test. All right, got kind of a mess of output here, but what we can basically see is that our SPY never succeeded. It just says bound method settings.save of blah, blah, blah. Now, you wouldn't know that if you haven't worked with this before. But to verify, we can kind of look at another function. We know that right here, enable SSHDB, that one worked. We know that we spied on that. It has a SPY object, which it's a little complicated, but depending on the kind of function you spy on, whether it's a top-level global function or whether it's a class function, you either have to add .spy to the end of it or you have to just work with the function itself. But I can basically verify that it's working for one, but not the other. So I'm going to go ahead and check. Go ahead and check this. Actually, let's go ahead and do something a little bit different. We're going to make sure that if we spy on another function that's similar to this, that's going to work right. I'm working with an extension instance here. The extension instance has a number of functions. We're going to go ahead and find one that works. So extensions, by the way, if you're unfamiliar, are a mechanism we use in Review Board to extend what the product can do, kind of like a browser extension. And that code lives in a module we have called giblets. So I'm going to look in here. We have this extension class. This is kind of what we're working with. You can see where we set up those settings, the object that has a save function that's not working. We're going to try to find something else. And let's see here. Shutdown hooks. That's a good one. Let's see if we can spy on shutdown hooks and what that looks like in the end. Let's make sure that the spying stuff is actually working right, in some form at least. So we're going to spy on that. We're going to go ahead and verify what the functions look like before and after. Okay, let's run those tests again. Remember, we're just kind of playing around. We're trying to figure out where are things going wrong, what's working, what's not working. Now, we've got another mess of output here, but what you will notice is that the old shutdown hooks function is a function on the class. These are called bound methods. A bound method is a method on a class that now is bound to an instance. So in this case, we can see that there is a standard shutdown hooks function. It looks just like the save function. But if I look down here, you can see that we now have a spy for the bound method. So what we know here is that this spy has worked fine. We've managed to spy on a function. We got the result we wanted. We have this object that we can now listen to. We can now call the called method on if we want to. And we know that works. So why does it work here, but not on the settings? So there's, many potential reasons, such as computers hate us. It's always a good valid one. But probably it's something a little more hairy than that. So we're going to start jumping around the code base here and figuring out what could be causing this. Now, that settings object is suspicious. There's something about this object, some reason why the save spy is not working. So let's see if there's anything weird about the save spy. We can go jump back into giblets here. So we construct in the extension that settings object. If I look up in the code, try to figure out where we import that, I see that it's in giblets.extensions.settings. So, okay, let's go open that. This is the object that manages settings for an extension. We look at the class definition, we see that it's based on a standard Python dictionary, which means we can treat it like a key value store, but that it has some custom behavior, things that are checking for default settings, returning specialized error messages, If we keep scrolling down, we see where it has that save function. So look at the save function. It's really just a save function. It's kind of strange, right? Like nothing, it's just a function. It doesn't look different from any other functions. No special decorators, nothing like that. So look around it. Nothing weird. Okay, so now what? Let's verify that the function we think we're looking at is the one we think we're looking at. Oh, by the way, this is not zoomed in well enough, so we're going to try to fix that. Hopefully that's a little bit better. Yeah. Okay. Once again, we're here in our unit test. We want to know what is magical about the save function. What is it that is so broken? Let's just go ahead and verify that the save function itself hasn't changed. So we're going to go ahead and just clean up some of this mess here first. Instead of looking at the string version of that function, let's look at the ID again. Remember, the ID is kind of like a pointer address if you've worked with C. It's the ID in memory of that function, or at least the ID assigned to it by Python. So we're going to see if we're dealing with the exact same function or not. And if I look at the output, I see that the numbers are exactly the same. So we are looking at the same function. So at this point, you got to figure out what is it that's causing this to not work. We know that the function is the same. We know we haven't replaced it with a spy, but we know that we've successfully replaced a separate function with a spy. So at this point in the process, we have a good sense that the settings object hasn't changed, that the function hasn't been replaced by a brand new function, that the spying doesn't work. So to me, that pointed towards something in the actual implementation of spies. Now, if you haven't dealt with spies before, they are a little bit magical. I want to first get into kind of roughly how they work. So when you're spying on a function, you're basically replacing that function. In Python, you have duck typing. You have this nice ability to kind of take an object and mold it how you wish if you really want to. You might have something like class foo with no object, or with no real body. And maybe you construct it, and maybe you start adding things onto it, like my custom attribute equals 42. Maybe it has something like a built-in value that you have then replaced with something else entirely. You can do a lot with Python. So what spies do is they take something like a function like test, and they basically replace it with something else, like a my custom test function. It's a little bit voodoo, as is being said in the chat. So they are pretty cool, but they are kind of hairy. I'm going to kind of show you what they do a little bit. Let me bump up the text here. Hopefully that's good enough. Just pay attention to, I guess, the left-hand side. All right. There we go. So when you create a spy, you are essentially constructing this thing called a function spy. It's just a class. Just a class that does terrible, terrible, evil things in Python. Stuff you should never do. This is basically the example of what never to do in Python, except for it is so awesome and it works so well. But don't do it unless you're using it through us, in which case do it all the time. Function spies are the core of our library, KGB. They are what do the function spies. When you create one, the function you want to replace or spy on is passed in. It's this second argument right here, func. And we do a few things. We check that it's callable. We check that it has these specialized sort of attributes. A function in Python has a few special things. They have attributes that tell you the name of the function, they tell you the owner of the function, and they tell you some additional stuff involving what the function has access to. And we use these to kind of figure out what we're working with, to kind of replace it, to kind of restore it. So the first thing that I would look at here is, I would say, are we even really truly calling this? And what does it look like? So in here, I'm going to go ahead and check for every single thing that gets spied on. We're going to look at the function itself. We're going to look at what funcname says. We're going to look at what IAmSelf says. IAmSelf is the thing that owns the function if it's in a class. So we're adding these print statements. We'll just kind of add a little marker so we can kind of differentiate it from other things. And run those tests again. Okay, well, these didn't really work so well because not everything that we spy on has IAmSelf. And you can see in the debug output, we only got this far. We got the first two print statements, the one that prints the function, the one that prints the name. And we see that this one has failed. So okay, let's not worry too much about all that. Let's just go ahead and no longer spy on enable SSHDB. Now the reason this failed is because enable SSHDB in our case is a top level function. It's not owned by a class. So it's not going to have certain state. It's not going to have IAmSelf. And we could worry about that, but we're just trying to get to the root of the problem here. We don't care. So if we have to wire things off, that's fine. When you're trying to deep dive into code, sometimes the best thing to do is to remove some of the logic that's happening. Remove as much as you can, so long as the code paths still kind of work, so that you can trace down what is actually failing. So in our simple case here, we're going to get rid of everything we don't care about, comment out the rest. We're just going to make sure that we're spying on this one function, save. We're going to try this again. And still no go, except for, yeah, no, it's going fine, I think. Yeah, so disable fails because it's spying on a top level function. First test here, we haven't modified that, it's still failing, that's fine. We only care about this one down here. We care about, let's go ahead and get rid of a little bit more here. We care about this last function, the only one that we're really concerned about this moment. So we're going to get this down to a kind of a base case. We know that spying on it and checking that it was called are two things that fail. Except for now we're no longer calling some of this other stuff. All right, let's get this further down to a base case. Only thing we care about, only thing the whole world we care about is whether we've got this called attribute on this function. So that's interesting, right? If you notice, this function's working now. That means that we've got a called attribute. But it's really because the previous function has failed. It failed early on. It failed in the spy, which means that what this function did impacted this function. This happens sometimes. You can write unit tests that pollute other unit tests. And when you do that, it's really hard to trace. I suspected this was what was happening last time, and what I had to do to kind of figure things out was to basically start um, essentially dividing my test suites in half until I found out what other classes, what other tests were really impacting this. So I found out a couple of things. I found out that this function will do it, but there's also one other function in the code base that does it. And I'm going to pull that up real quick. I found out that this function also does it. Test sync licensed users. Now, you'll notice that this is also spying on settings.save. Kind of strange. This is the only other test in all of PowerPack that is spying on this, and this is the only other test anywhere that impacts whether this function works correctly. So that points to some interesting stuff. Kind of tells you that somehow one test is affecting the other one. Now, you're going to spend a lot of time debugging stuff where you're not going to really know what's next. You're not going to know why things are broken. You just have to try things, just have to gather information. I could show you all the stuff I did to try to divide and conquer, but it's not too interesting. I guess maybe this will be useful to you, some of you people. So what I did is I kind of looked in every place where we had like a tests directory or test file. That's kind of all of them. And I started specifically running certain test suites. And you can do that in any kind of Python test runner by typing like a full module path. So rbpowerpack.pdf.tests or beanbag licensing.tests.test license, anything like that. I'm getting those from these lists above, modules and the more specific modules. So in the end, I found out it's those two places. Okay. So what would you do next? Well, you probably want to get things working again because this test is working now because this one's failing. So that kind of sucks. We know it's failing because of the print statement. We know it's because of this. So let's go ahead and just simplify this a bit. We're only going to print this if it actually exists. We should now be able to get back to a point where only this test is failing. It should no longer have that called method. See, there we go. While previously it had called, now it does not. So we definitely know that other tests are impacting this one. Whether these ones can spy are impacting whether this one can spy. So let's find out a little bit about what is getting stored and why that may not be working. We're going to kind of dive back into function spy here. Now, looking at the debug output, we see that we've got the string version of the method we're spying on. We've got the name. We've got the owner. The owner is that settings object. You can see it even has that key that we've set. Except that's kind of interesting. If you notice right here, this has a value of sshDV keys imported set to true. The extension settings already have a setting. Now that would have happened when calling, when manually setting the key, or eventually when calling check enable, which goes through a whole process that eventually sets this kind of value. But if you look in this test here, we've never set this. Settings should be blank, but it's not blank. It certainly shouldn't have this value, but it had that value up here. So at this point, you got to wonder, what's happening? Why is this setting actually set? So let's look again at the objects that we're dealing with. We know that we had the IDs before of the settings and they matched. If you remember, we printed the ID. There we go. We printed the ID of the settings before and after, and they matched. Let's go ahead and do that again, but let's do it up here. We're going to go do that in the test that's affecting this. And we're going to actually force this test to fail because we want to be able to see that output. All you have to do is assert false or type gibberish, anything really that's going to cause it to fail. Except I typoed. So let's correct that. Now, a debugging session is not going to necessarily be quick. I'm sure many of us have encountered the week or two long debugging sessions that led to a one-character typo, were caused by a one-character typo. If you haven't done a lot with big development and really hairy code bases, you might be spending a lot of your time doing this kind of a thing, where you're just basically trying to solve problems for weeks on end that tend to be, or turn out to be very simple in the end. All right, so the first test here is showing that we have IDs that match. Okay. Second test here is showing an ID different from those. Okay, that's good. That means that each unit test has its own settings object. One should not be polluting the other one. And we looked earlier at the definition of the settings object, and we saw that when it comes down to it, it's just a dictionary. We're setting stuff in the dictionary. Dictionaries shouldn't be replicated like this. So, that's quite interesting. Let's go look at the content. We now know from this debug output, when looking at the bound methods owner, that it has content. Let's go verify that we have that content before we call the spy. And we don't. As it should be, the settings object is blank. The one that we've actually worked with, the one that we've created, or that has been created for us in this unit test, is blank, the default. But when we look at the function we're spying on, it has a value. It has the same value, in fact, that ends up getting set up here. We can kind of verify that. By the way, some of you may be very comfortable in a debugger like PDB, sorry. I'm a print debugger. I put print statements everywhere. I like to go see an entire trace of every value I care about every time I run the tests. And, print it out in paper if I need to, put it on the wall. All right, so we can see here that this matches the result from the previous test. So, going back to the function spy, that value, the one we're seeing here, the bound method that has the populated key here, is coming from func.imself. That means the function's owner has content. And it has the same content from the previous test. That indicates that the previous test's object is remaining around somehow. It is being associated with that function for the following test. That's no good, and probably is related to why we can't spy on this thing. Let's go ahead and print out a little bit more here. We're going to print out the ID of the owner, just to verify, see what it looks like. It should match the ID of the settings object we've created here. Okay, here's the number, blah, 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 032. Well, that's not this at all, but it is this. We've now confirmed here, like looking at these IDs, we now know that somehow the settings object is leaking. Okay, so then why is it leaking? Well, I have to go trace code to find that out. So we have a pretty good idea now that somewhere in this function things are going very, very wrong. Now this function does some hairy stuff, and I could do a whole talk on what it does, especially this fun block here that is basically taking Python bytecode, swapping it out, and taking the brains of a function and giving it a transplant. It's a bit weird, but I need to understand this function now. I need to know exactly what it does. This thing has to become very, very clear to me. At least the call paths that get executed have to become very clear to me. I need to know how we got to a point where this state has changed or has been preserved. So I'm going to start tracing things a bit. I know based on how I'm calling it. Let's see. Let's go look over here. We're calling spy on with the save function and with call original equals false. That's telling it don't call the actual function that we spied on, just basically make it an empty function. And we can kind of look at the defaults here. Call fake doesn't have any kind of real value to begin with, and by default we are calling the original function. Okay, so we now know some stuff about how this function is called. That can help us narrow down what we're doing here. So we don't care about this. Value's none. We've already set call original false, so we don't care about this. So we now know that the self.func is going to be none. Maybe we don't know what that means yet, but we know that's going to be none, so we can kind of figure that out. Now we're here. We know that it has an IAmSelf because we've printed it. We've already printed that. And we know that IAmSelf is wrong. Okay, so cursory glance. We're in here. We're checking if it has a value. We're setting the owner. Otherwise, we're setting it to something else. IAmSelf is the attribute that says, here's what my owner is, if it's a method on an instance of an object. If it's a method on a class, one that has not been instantiated, the attribute is going to be IAmClass. So we know it's going to be one of these. Okay, but we've already looked at IAmSelf, and we know that there's something there, so let's move on. We can just go ahead and assume that self.owner is correct. And then we go and say set attribute, self.owner, self.funcName, self. Okay, what does this do? Let's go ahead and kind of reason this out. We're setting on the owner, on func.IAmSelf, we're setting on that an attribute that is the function name. So in this case, it's going to be save. And we're setting the value to be self, which is going to be the function spy. Let's just go ahead and view that real quick. We'll just say, we'll just print out what it is this is doing. So we can get a good sense, just make sure it's kind of roughly what we think it's doing, or what we think it is. There will be recordings of this later, so if you've missed stuff, don't worry about it. You'll get to listen to me ramble as often as you want. Okay. So we see here that we're setting the attribute on that broken class. We're setting it called save, and we're setting it to the function spy. Okay, so we still know here that we're dealing with the wrong function. Up here, it looks fine. Up here, we're setting it on this. It's kind of odd, though. We'd expect it to be a bound method function. We expect it to look like this. Sorry, we'd expect it to look like this, because we're working with an instance. We're setting an attribute on a class now. That's strange, right? If we look at this code, the whole idea is that the instance owning the save function, should be getting this value overridden, which is happening down here. But in the presumably working function, it's not happening. It is, in fact, setting it on the class. This is where the light bulb went on for me. I started to realize there's only one place where self.owner can be set to a class, and that's here. It's strange, though, because we've already verified there's a value up here. We've already printed this. Now, for a little while, I started going, I've gone completely insane, and I don't know how programming works anymore, which is also a perfectly valid feeling when you're a developer. And I started printing a bunch of stuff out. I thought, okay, let's go ahead and print some stuff again. Let's just go verify right here that IAmSelf is what we expect it to be. Remember, part of debugging hairy problems is just becoming very familiar with everything that's being called and what the state looks like, what values look like, what order things happen. And you should be able to feel comfortable enough just dumping print statements in whatever modules you're working with, even like official Python modules if you want to. So we have kind of a mess of output now, but we have 1, 2, 3, 4 values that we printed here before setting the attribute. Looking for the one saying IAmSelf equals, and we see it here. IAmSelf equals blah, blah, blah. But we already know this function's messed up. Let's look up here. IAmSelf equals an empty settings dictionary. Now, settings is a dictionary. And we now want to verify that when we cast it to bool, which is what happens when you do like if something, colon, if we cast it to bool, will it be true or false? Will it be, oh, false. Okay, so what did that just do? What did we learn from that? We learned that this value, we learned that the owner of this function, when we do an if statement on it, it will return false. Well, that makes sense because we're doing an if statement right here, and it's false. And that's what's causing us to fall back on this class. Well, it's a pretty clear indicator something's very wrong here. IAmSelf should be, what we're actually wanting to check is whether it's none. It'll be none if it's an unbound method on a class, if it's on something not yet instantiated. But we're just checking if it's truthy. Well, an empty dictionary is not going to be truthy. So we actually have a bug here, and it wasn't even in the unit test, it wasn't even in PowerPack. We have a bug here in the actual implementation of function spies, not where we were expecting problems to happen when we first set out to debug this. Whoops, okay. What we actually want to do is directly compare that to none, so that an empty dictionary doesn't set it off the wrong way. Question is, why has this, just got thrown around this file, why has this caused the problem that we think it's caused? Well, let's first verify that things now work. We're going to go ahead and stop the forced failure there. Let's see if unit tests pass. Not quite, not quite. So we're still seeing the same sort of problems here. So let's verify that we've actually done the right thing. We've got the set attribute. We still have it on the old one, right? So let's go ahead and re-enable this assertion here. It's still going on the class. Oh, and here's the problem. I didn't save. That's going to happen more often than anyone cares to admit. I didn't save, I forgot to commit, I forgot to pull. Okay. Going back to running all the tests without any forced failures. Hey, it works. It works. So the core problem we had here was a very simple thing. We were just checking if something was truthy, but it was valid to have a value in there that might not be truthy. What we needed to do was check if it was none. So now we've got to understand why was that change? Why did that fix things? Okay, so we know that we were dealing with an object, a parent owner of the function. dealing with an object that could evaluate to false in a simple if statement like this. We know that that caused the problem, but why? Why did that cause the problem? We may have solved it, but it's always good to know the reasons that your solution has fixed things, because if you don't do that, you're going to eventually write things that look like fixes that might mask other problems. Call them band-aids. So what we knew is that the owner was incorrect. We set the owner to the class, and then we set the function on the class. And then if we look further down, when the spy, we have this function called unspy. It's what happens when the spy is to be removed after a unit test is completed. We were checking if this has the attribute of IAmSelf, which we know it does, then set the owner, set the attribute on the owner to be the original function. This is why it failed. This was doing settings dot save equals the original function, instead of the extension dot settings dot save equals the original function. This is pseudocode because these can't actually access these objects. But this is the difference. By having that Boolean check instead of the comparing to none up here, by having this instead of this, we have started working with the settings class, not the settings instance that we wanted to work on. Which meant that once that test was completed, the default method for the settings object was using the wrong thing. We were saying that this function's IAmSelf is always going to be that previous instance we worked with. So while settings.save equals self.arigfunc, so what we ended up with, we were also doing we're also doing that. Which meant that that function from here on out, every single time it's ever called, was going to assume that it was owned by the very first instance to have spied on it. Which is why we had the invalid keys in there. That could cause a lot of problems, and it could also mean that potentially there are unit tests out there that are appearing to pass, but have actually failed. Now, it's kind of rare because you're going to get, most unit tests are going to be checking the kind of values that we were checking originally that led us to notice this in the first place. And most classes aren't going to be evaluating to true or false. But we now know here that we had a bug, a pretty bad bug in our function spies. And by tracing through all this, by printing out information, printing out IDs, comparing values, and just generally going through as much as we could, just diving in and learning about this code, we were able to go and really solve this problem. Now, this might have seemed a little complex. Maybe it didn't all make sense the first time. Might be worth watching the video a couple of times. But if you've worked on a review board, if you've worked with unit tests, and you've had some really kind of hairy code paths that you're working with, things that don't quite make a lot of sense to you, this is what you have to do. You really need to go line by line. You need to figure out what's being called. What do the values look like? Try to really understand all that. Try to make sure that starting at that unit test, you have a perfect mental picture of everything that's happening in it. Because that's really the only way you're going to be able to fix the problems that you're looking at. It's the only way that you're going to know, why did this work? Why did this not work? So that is basically what I had to go deal with last night until almost 5 in the morning, fixing this, which ended up being a simple replacement from this to this. Not the worst thing I've done. I once spent 2 weeks trying to debug a problem that was due to 2 lines being swapped. And there's another time I spent at least 2 weeks dealing with something that was just a 1-character typo. So these things happen. They absolutely suck. At the end of it, you just don't want to go and do any more programming for a while. Totally fine, totally normal. So that's basically my little deep dive demo. And if anyone has any questions, I am happy to answer them. In the meantime, I'm going to go and restore this back to where it was, just to make sure that everything still passes correctly. Ta-da! Also, once you've fixed a problem with the test, it's good to run the entire test suite because you really need to make sure that you're not suffering from other similar problems, other test leakages, or somehow impacted another unit test. So you can ignore all of these because these are actually some Django bugs, but it works. So that's basically my stream. I'll be archiving this if you've missed part of it. If you want to go back and pause and kind of look at the code as I go through it, try to understand it yourself. I recommend you do that. Hopefully that will be helpful to you. And I will be available after the stream to kind of answer any further questions in that. I know a lot of this that I covered today wasn't directly related to what you're working on, but the concepts still apply. And so it's a good habit to get into. Being able to do this stuff well is what builds a really strong developer. The developers who can deep dive, who can really go in and fully understand a code base, those are the guys that are doing the big work out there because they're learning constantly. So I recommend fully that you do this even for practice. Pick something in review board. Learn how the whole thing works. Learn the tricks. Learn everything about it. And you'll walk out of there being far more knowledgeable with some really good experience on your hands. So thank you for watching. And I'm going to end the stream now.